All right, full screen. Here we go. Chapter 10. We did skip Chapter 9. Chapter 9 is conic sections, which you'll learn next year, probably second semester in your pre-cal class. Fantastic. I wish we didn't skip it. Boy, conics is fun. But you're going to have to wait for that kind of fun until next year. So we're in Chapter 10. The title of Chapter 10 is Counting Methods and Probability. So of our chapters, it's probably the least mathy. It's quite wordy, a lot of word problems, a lot of kind of common sense, if you will, thinking, and practice. The more you practice, I think the better you get at it. Also, I wanted to let you know that I think I'm going to switch. I'm going to flip how I grade your homework. Ha! How does that sound? So I think I'm not going to check and see if you have watched the video anymore. I hope you'll watch it. I feel like, maybe you're, more worried about writing everything down so as when I come and check it. So I think you should get homework credit for doing homework in the classroom. So if you're in class and you've spent an hour, doing problems, you'll get homework credit. If you're absent one day, you'll have to make up that worksheet that we do in class, which I think is fair. So I'm not going to check your notes anymore. And I guess the reason I'm doing this more than anything is that, for some of you, you may just want to sit and listen to the video and really not write much down and just kind of hear what I'm saying and learn from it. And, feel free to write down what you think is important instead of just writing everything down. So I hope that helps. And I'm all ears. If you don't like this system, let me know. Anyway, so here we go. So this is section 10.1. It's called Applying the Counting Principle and Permutations. So what is a permutation? It is an ordering of n events, and permutation is going to be a big deal because we're also going to do a combinations. And the difference is permutation, we care about the order in which things occur, versus a combination where we're not really that concerned about the order of our picking. But permutation, we care about the order in which we put objects, if you will. And we also have this thing called a factorial. Factorial is really cool. This is like if I wrote 4 factorial, and you should be saying that's 4, like yelling 4. No, it's not 4 exclamation point. That exclamation point is now called factorial, and it's a symbol. It's a notation that math people came up with because they're lazy. That really means 4 times 3 times 2 times 1. And you can appreciate why I picked 4 factorial, not 20 factorial. If I had written 20 factorial, we'd be here for quite a while because I'd have to write 20 times 19 times 18 times 17. Tell me when to stop. Times 16. You can't. Times 15. Right? We'd have to go all the way to 1. So you can appreciate that, math folks said, look, if I have to write multiplication like this, it's a nice system to write 4 factorial. And I'll show you in a second how your calculator can do it. You'll like that a lot. So here's example 1, right? You're buying a pizza, and you have a choice of 3 crusts, 4 different types of cheeses, 5 meat toppings. That's a lot. I wonder how they did that. And 8 vegetable toppings. So they're asking you, how many different ways can I make a pizza of all, take 1 crust, pick from one of the 4 cheeses, pick from one of the meat toppings, pick from one of the vegetable toppings. And so what we end up doing is we multiply the number of choices. You have 3 choices, 4 choices for cheeses, 5 for meats, and 8 for vegetables. So the fundamental counting principle tells you to multiply your number of choices. And so again, the number that we're looking at when I multiply, I don't know what that number is, I had to look at my notes, is 480. So there are, 480 different pizzas that you could come up with that, 480 different pizzas that you can come up with these different possibilities. So you'd have like a whole wheat crust with cheddar cheese, with, meatball, with broccoli, and then you'd have another way to go about it. So again, fundamental counting principle says multiply your number of choices. So we have to talk about, fundamental counting principle when we have repetition. So phone numbers is a nice example for this, right? So you have a town, the first 3 digits are 3 to 9. That really doesn't mean anything for us, followed by 4 digits. So how many different phone numbers are possible if the numbers can be repeated? versus cannot be repeated. So I typically, I like to write this, like if I have 4 choices, I write 4 spaces. And so I say, okay, well, the first digits, the first, this, again, phone number, you'd have 329 dash. All right, how many digits can I pick from? Well, 0 to 9. That's 10 choices. And then I'm allowed to choose with, I can choose the same digit again. So again, I have 10 choices. And then I'm allowed to pick from 0 through 9 again, 10 choices, and then 0 through 9 again, 10 choices. So when I multiply these 3 numbers together, I get 10,000 different possible phone numbers, with all starting with 329. So this next scenario, which I don't know how, if any town ever does that, but they say you can't repeat the digits. So you couldn't have the phone number 3294444, right? So what happens here is, again, think about how many choices we have, right? We're going to fill in 4 places. And the first time I can pick from 10 digits. But notice, like, let's say I picked and I put a 4 here. I can't pick from 4 again. I can't include 4, so now I'd only have 9 digits to pick from. And let's say I picked a 3. A 3. Then I would only have 8 digits, right? Because I could pick from 0 through 9, but not including 3 and 4. And then I would have only 7 digits to pick from. So your possible choices here, I have to look at my notes, is 5,040. Notice how aggressive that is, right? That means half your choices would go down. Hope that makes sense. So here we go. This is, next example is finding number of permutations. So you have 8 teams competing in a baseball playoff. So it says, in how many different ways can the baseball teams finish the competition? So each team is unique, and realize, you could have whatever team, blue gets first, then team red. You would have basically 8 factorial. 8 factorial means, and again, you would think of how many places. Well, there's 8 places if there are 8 teams. Right? And the first time, whoever gets first, there are 8 possible teams. Well, the second place, you've already picked one of the teams, or one of the teams has finished in first. So it would drop to 7, 6, 5, 4, 3, 2, 1. And so I'd like to show you right now on the calculator how we can do the factorial. It's under the math button. So if you go here, you type 8, and then you would hit math and go over to, see this word probability, that's the unit we're in, probability. And there you see the factorial symbol, number 4. Again, 8 factorial is 8 times 7 times, we can, if you need me to prove it to you. I bet you did need me to prove it to you. I'll even do times 1, but that's kind of silly. The same answer. Again, it's just a nice way. It'd be fun if you see what the biggest factorial number your calculator can handle. That's a neat bonus question. So back to here, right? So you would have, I forget what we had for an answer. I think I have to go back to calculator. So this was 40,320. And so now the second question is, in how many different ways can 3 of the baseball teams finish first, second, and third? So here I would say, well, I've got 3 possible choices, right? First place, second place, third place. I'd have 8 teams to pick from, 7 teams to pick from, 6 teams to pick from. And that answer, of course, is going to be smaller, is 336. And that brings us to the formula for permutation. Pretty fancy formula, right? Definitely want this on your note card. And what happens here is, like, we could do the last problem we just did, where it's saying the number of permutation of R objects taken from a group of n distinct objects. So if I had 8 teams to pick from, and I want to place first, second, and third, that's 3 picks. And so here this would be 8 factorial divided by 8 minus 3 factorial. And so this is the same as 8 factorial over 5 factorial. And then we kind of expand it. We say, look, this 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2. Always feels silly to write 1, but whatever. Right? Multiply by 1. 5 factorial is 5 times 4 times 3 times 2 times 1. And then hopefully you see, hey, 1's cancel, 2's cancel, 3's cancel, 4's cancel, 4's cancel, 5's cancel. And you're left with 8 times 7 times 6. And notice from the last slide, that's the same thing we had. So that's nice, especially when you get into bigger numbers. So let me show you on the calculator how you can do this. So here we go, let's clear this up. We would type 8, then we'd go back to the math button, over to probability, and notice there's the NPR button, enter, and then I'd have to put a 3, enter, and you should get the same answer, 336. So nice, calculator is a nice tool here. Let me get back my pen. I think I'm done with my calculator. Go full screen again. And then, so here we go. This is kind of another example. So here you'd say you have 6 homework assignments to complete over the weekend. However, you only have time to complete 4 of them on Saturday. In how many orders, and this word order is huge, right? They're not just saying like of the 4, of the 6 homeworks you're going to do 4, but the order in which you do those 4. First you do math, then you do history, then you do science. So the order is important. Again, we're next section we don't care about the order. Anyways, you have 6 factorial over 6 minus 4 factorial, which is same as 6 factorial over 2 factorial. I think the book then, just gives you what 6 factorial is. Again, here I'm kind of hoping you'll be on the calculator right away, but you may decide to do this manually, and you should get 360 different ways that kids can compete. So why don't you go ahead and try to do these example problems right now. Good idea. Just it won't take you but a few, 2 minutes, and I think it'll really help. Hit play when you're ready. And here we go. So 7 different telephone numbers. I think you really have to write 7 times, right? And then it says here from example 3, you have 6 teams. How many ways can they compete? And that's just 6 factorial. And then finally, if you had 9 chores and you had to complete 5 in order, right? How many you do, you do the dishes first, then you'd mop the floor kind of thing. That would be 9P5, and hopefully you plug that into your calculator. Nice job. Hey, last thing we need to talk about is permutation with repetition. So what if there are, there's a repeat, like, on your chore list, you have to feed the chickens, and then you have to feed them in the morning or the night. I don't know if that makes much sense. Usually we do repetition with letters. So think of Scrabble. So maybe we start with an easier example. Like, what if I ask you how many ways I have I have 4 letter pieces in Scrabble, right? M-A-T-H. I know it spells math. How many ways could I rearrange this order? And here you should say, well, you have 4 tiles to pick from. Then you have 3 tiles to pick from, then 2 tiles to pick from, finally 1 tile. So that's 4 factorial. But what happens if you have with a repetition, like E represents twice? And what we'd end up doing there is we say, okay, total number of choices, but let's divide out the repeat. So there are 2 E's, so I divide out 2. California here is a little bigger, right? So the total digits in California, just trying to speed this up, there are 10 digits, so it's 10 factorial, and if every letter in California was unique, I'd be done. But check it out, there are 2 A's, so I have to divide by 2 factorial for the A's, and I'd have to look, what's the other one? There are 2 I's, and so I would have to divide by 2 factorial for the I's. Let's say there were 3 I's in California, then you'd have 3 factorial. And be careful when you type this in your calculator, you have to put parentheses around the 2 factorials. You can sometimes outsmart it, right? 2 factorial is just 4. So you could type 10 factorial divided by 2 factorial. Hey, try these 2 problems, tomorrow and yesterday. Set them up, and I'll give you the answers. Ready, set, hit pause.